0.
The mean is 0, dead center, yes. 1 second. I totally forgot to do this. One second. Oh God, is this thing working? We're about to find out. Hey, look, it's the back of Max's head. Nice. Did you get a number? Let's see. That one minus that one. Yes. Yes. Did you get a number? Oh my gosh, yes. You got it? So did you get the percentage number of this one and this one? Really? 1.5. Rules. Number? Okay, so we're going to get ahead.
Like at 6 a.m.
Maybe
1.5. 6 a.m. I'm in 7 a.m. When school starts, it's first period.
Did you get a number?
I did.
Yes. Perfect. Okay, if you're not sure, folks, here, I can show you real quick. Or real slow. Here's negative 1.5 on my chart. Here, let's do that. Make it bigger. Yeah, let's do that. Okay, negative 1.5 is 6.6%. 0.0668, right? Right there. That's negative 1.5. 0.0668. Positive 1.5 on the other side is right there. 93.3. 0.933. If you take 0.933 and you subtract 0.066, you should get about 87%, 86%. We're going to call it about 86%. 86.something%. 86.6 sounds right. In fact, I can tell you the actual retail price is not that. I have it right here on my screen. I cheated though, because I'm a big cheater sometimes. I use the calculator thing to do it for me. It was from negative 1.5 to 1.5, right? There's the actual retail price, 86.6%. Okay. Let's flip on over here to the next page. We're going to talk some tenants today. A distribution of test scores is approximately normal, and Joe scores in the 85th percentile. How many standard deviations above the mean do you score? What we're going to do is we're going to show you how to take this chart, and we're going to go backwards. Can you go backwards? You can totally go backwards. Okay, so here is from Z percent. The dead center would be the mean. There's 0. There's my 0.5. Okay, where's 85th percentile? That's way over here somewhere, right? Can you use this and go backwards and get a Z-score, or how many standard deviations will it be? Can I go backwards? Well, what that means is you're going to take the little yellow chart here on the positive side, and you got to find 85%. Whoa, where's 85%? Well, here's my 80s. There's my 70s. 81, 84, 84.8. Check out right here, I'm going to draw a circle. Do you believe me that 85% is somewhere right in there? 85% right here in the dead center is a Z-score of 1.35. I call it 1.35, just call it right in the middle. 1.35. So yeah, you can go backwards using the chart as well and get the how many standard deviations. How about this? In a normal distribution, Q1 is how many standard deviations below the mean. Who do you remember what Q1 is? As opposed to Q3? That's power numbers. Remember what Q1 is? The median is the 50th percentile, right? Median, dead center. You buy that? Here's median. 0 is over here. Here's 0, here's 50. What's in between those two? You know, like $50, you need to share. That's the 25th percentile. Q1 is 0.25. Can you find 25% in here? Hey, wait a minute. I don't see a 25% anywhere. I see 50, I see 99, I see 92. Where the heck's 25%? She like took a paper and she went, it's over there, buddy. You gotta flip to the other side because it's a negative z-score. It's less than the mean. 25%. 25. Where's 25? I see 28, 22, 20. Come on, dude. 25. Here's 0.025. Oh, it's down here. 23, 27. I found it. The 25th percentile is right here. I just circled it. It's down in the bottom right corner. There's 0.2514 and 2.2483. You believe me when I tell you it's somewhere in between there? This would be a z-score of negative 0.675. Negative 0.675. That looks weird with my negative inside my decimal. Don't ever do that again. Or about negative 0.68 if I round up. I just found the one in the middle. I didn't subtract those two dudes. So this says 25 and 0.414%. This is 24.8%. I want 25%. So it's in between. There is no exact 25%, right? So it's somewhere in between them. Okay, so what I did is I took this z-score, negative 0.6, way over here, whoops, way over here, left, see the negative 0.6, and then I went across, okay, negative 0.6, 0, 1, 2, 3, 4, 5, 6, that's negative 0.67. This is negative 0.68. So I just went between. Yeah, it's somewhere in between. You'll never have to use this yellow paper after today because when I try to use the calculator, I just want to see who use this. All right. So this one would be about negative 0.675. Yep. All right, let's show you how you put this in action into a real situation, a real story. In 2008, when Lieutenant Stern, Rocky Nadal averaged 150 miles per hour on his first serve. 115, that ain't nothing, man. I hit a golf ball way faster than that, like way faster. Meaning if it hit you in the head, it would kill you instantly. I'm dead weight. Actually, I almost hit a friend of mine in the head. It was scary as all get out. Hit him in the shoulder right back here. My friend Ted the assassin. And everybody got mad at me because I hit Ted with a golf ball. But it's funny, everybody got mad at me when Ted hit me with a golf ball. I don't know why that is. I still have issues over this. Okay. So anyway, he hits 150 miles an hour on average. Assume the distribution of the serves is normal. Oh, okay, so it's a bell curve. Mean is 115, we know a standard deviation of 8 or 6. I'm going to draw that story right over here. I write raw z percent, give myself room to put 3 rows of data under there. The raw mean, they told us, is 115. That's right there. That is the z-score of 0 and 0.5 for 50th percentile. That's not going to change. About what proportion of his first serves would you expect to be 120? Okay, so 115 is here. That means 120 is somewhere over there, right? Don't know exactly where, but it's somewhere over to the right. And the question is, what proportion of serves would you exceed 120? I always shade it in so I know which one I'm talking about. I want that percent. If you get an answer like 90%, you're wrong. It's got to be less than half, right? It's not very much shaded in. So what we're going to do is we're first going to find this value, and then we'll find that value. So step 1, that dude, step 2, get the number below. We have to find a z-score. We have a little formula for z-scores. It looks like this. Z equals x minus mean over standard deviation. The x in question is how fast he's hitting the ball. 120. The mean is 115, and standard deviation in this case is, they told us up in the beginning. There it is right there. And then this one is this. That's over 6. 120 minus 115 is 5 divided by 6. You know what 5 divided by 6 is? Hello. What are you doing in the calculator? Why are you freaking out? Press any key. Does none of the keys say any on them? Okay. 5 divided by 6. I get 0.833. That's the z-score, 0.833. I'm that many standard deviations above the mean. The percentile for 83.3%, well, you're going to have to find the z-score. It's down the chart over here, 0.833. Point A is right there. And then you go over to 0, 1, 2, 3. I just circled it. That's 79.7%. 0.797. That's the stuff over here to the left. That's the 79 over there. I don't want this one. I want this one. So I'm just going to take my calculator and do, 1 minus 0.797. I get about 20.3% for answer. That should pass my VSO meter. Is that about 20%? Yeah, that could be 20%. I just sketched it in there. It's definitely less than half of it. He hits about 20% of his serves at least 120 miles an hour. Even though his mean is 115, so every now and then he cranks it up, right? Yeah, I totally do that. When I get to the 17th hole in North Bellingham, I turn a little harder. I get my hip through a little harder because I'm trying to hit the ball over this bunker all the time so I can get to the green and two. So, yep, it happens. All right, let's move on. What percent of his first serves are between 100 and 110? 100 and 110. Huh? Here's my raw Z percent. The mean has not changed. That's 115. The Z-score here is 0, and that's 0.5. And I'm just going to use my chart to figure out where are 100 and 110. 100 and 110 are both down here on this side, right? There's 100. There's 110. I'm going to get Z-scores for both of those. Turn them into percents. And then if I subtract them, I can figure out what percentage is in there. We're looking for that space. Why would anybody ask that question? Geez, you know, you hit the ball pretty hard, dude. But how often do you hit it between 110 and 100 miles an hour? It's so random. It's like wondering what percentage of the girls that running NASCAR are between 5'7" and 5'9". Would there be any reason to know that? Maybe if I had like a door, you know, and you have to be this tall to ride this ride, but the door, you like hit your head on the door if you were too tall. Doesn't make any sense. Okay, we're going to need 2 z-scores. There's going to be a z-score for the 100. There's going to be a z-score for the 110. So it's going to require 2 z-scores. Using the same formula right here. 100 minus the average, which is 115 over 6. This is going to be 110 minus 115 over 6. Up on the top, I get negative 5 divided by 6. That's easy. That's negative 0.83 because I already did 5 divided by 6. I got 0.83. So this is negative in that case. Down here. Did I do that right? Well, that's negative 15, isn't it? Oh, that's wrong. Ooh, this one down here is negative 0.83. 15 divided by 6 is negative 2.5. Okay, so this is negative 2.5, and this is negative 0.83. We're going to need some percents. Boy, those are tiny. You can read those in there? How about now? Better? Okay, negative 2.5. Negative 2.5. Negative 2.5 is right here at 0.0062. And then the negative 0.83 one, negative 0.83, way down here. 0.2033. Oh, it's the same as the one up there. That's I should subtract those. Take 20.6 minus 0.06. 0.2033 minus 0.0062. 19.7%. I feel like going too fast, so if you want to back up and say, hey, where did that number come from? Now's a good time. Or if you totally get it and you feel smart, you can tip me. Give us your shit color.
That would be nice.
Hey, if you're gonna tip the person who makes your coffee in the morning, you can totally tip your math teacher, right?
I just played the first three and first times, first time and first time somewhere.
What's that?
So it's just the first three numbers and turn it to percent.
Yes. Take the z-score, turn the z-score into a percent. And then in this case, I subtracted the two because I took the upper one minus the lower one. What's that? There's coffee and bagel on it. That's important.
Well, like at cruising or woods or.
Are you talking about tipping people?
Now since she has a 10 question.
You don't tip your coffee people?
For Starbucks, you tip for Starbucks? Do you go to Starbucks all the time? No. Or do you tip all the other places? Multiple places, yeah, but not like Starbucks. Stuff like that.
All right, you can still use the first one. All right, I gotta answer Max's question. I'm sorry, Max, I couldn't hear what you were asking.
How do you find percentile?
How do you find the percentile?
Yeah.
So you take the z-score. You gotta get the z-score first. Are you okay with this fraction right here, Max? We're calculating how many standard deviations above or below the mean something is. And then you take the z-score and you turn that into a percentile using this chart. We're gonna get rid of the chart here pretty quick, okay? Hey, let's do another one. Fastest 30% of the servers. The fastest 30% of servers. How fast do they go? Fastest 30%. That would be the 70th percentile, right? If you're in the fastest 30%, we're looking for that one all the way to the 70th percentile. You can look at it as going backwards 30 or forwards 70. It doesn't make a difference either way. Raw Z percent is raw mean is still 115. Is raw Z score is 0 here, and that's 0.5. The fastest 30%. Oh, let's actually start at the bottom of the chart. So if you're in the 70th percentile, that's 0.70. What we're going to do is we're going to go backwards, get a Z score, and then we'll go backwards and get a number. So it looks like this. All right, gotta find 70% here in the chart. It's not a Z score. See if you can locate the 70th percentile. It's on the positive side. I think I found mine. I'm circling it right now. It's somewhere in there. 0.525 sounds good. We go with 0.525. 0.525. After I know the z-score, we're going to use this equation. Z equals x minus mean over standard deviation. Check this out. I know that. I know that. I know that. Can I find the one that's missing? Totally can find the one missing. 0.525 equals x minus 115 over 6. I just filled in the numbers that I knew. Oh, it's algebra. Ew, I thought you said there'd be no algebra. This is as bad as the algebra gets. Two-step algebra. This is as bad as it gets. You know, it's like, no, come on, you seriously? No. Let me ask you this. Do you know what 2 steps to do to solve this for x?
5 to 5 times 6.
And then?
Then you add
What are you shaking your head like it's hard? You totally know what to do. It's stupid easy for you. You didn't even need to see an example to know what to do. Are you just a whiner? Can anybody confirm that?
I agree.
Are you like super tough, hard as a rock nails kind of person and you're just doubting yourself?
Sorry, did you hear Jeff? She said she seconded that.
You say.
No, I seconded whatever. Olivia said first.
So here's the answer I got. I put it in my calculator. I believe that's 115. That means the fastest 30% of serves go at least 118. They definitely go faster than his average. 118 miles an hour. That's a tennis ball. Would you want to get hit with that tennis ball?
They actually go that fast.
Oh yeah. Yeah, like I said, golf balls go way faster. You know, there's listening to my math teacher talk about it, and then there's the answer Google. How fast does a golf ball go? 211 miles an hour. Formula One car, whatever. NASCAR, they get up to like 199, 195. Golf ball,
What's your fastest person?
Those things have just, I've never been hit before, but I just feel like it probably hurts. So,
I think that was the tennis ball.
how fast does baseball go? It says speed increases 195 to 130 mile an hour. So they can be cranked up to about 130. They call it top end. That's Serena. You've never seen Serena or his sister Venus? They look like freaking bodybuilders. They do not. They look more dude than women. Because they're just like they got rippling muscles. It's scary looking. Both of them. So Billie Jean King used to look like that in the 70s, scared the hell out of people. That was if you guys are wait, you're not juniors, sorry, so you're not in culture history project. Anybody did that last year and put Billie Jean King in as one of the people? I'm doing it right now. So Billie Jean King is really popular in culture history project. He comes in for battles with Chris Everett. Chris Everett was a tennis player who was very feminine. She just looked feminine. You know what I mean? So Billie Jean King had rippling muscles, and she was strong, and she beat the hell out of her, and people didn't like her. You know, she was unpopular.
Wait, the big girl?
Yeah, Billie Jean King was a strong woman. She looked it too, you know. And Chris Everett was this dainty little feminine gal, and Billie Jean King beat the hell out of her. So, yeah. And then she became more famous when she beat the dude. This guy challenged her. This guy challenged Billie Jean King to a match, and she crushed him. Yeah.
Oh, wait, I remember where you got.
Yeah. So they made a couple movies made about it. So. Anyway, okay, random crap for the day. We need to cruise. How are we doing on time? It's 10:28. We're out of here at 11:25, right? So we have an hour. Yeah, because we got teacher, so we got to 11:25. We had a longer period today. We want to keep droning. If you guys need a break, do you want to take one now, or you want to keep going for a little bit and then take a break?
Keep going, your mind.
Yeah, we'll keep cruising here. We'll keep going. We'll get to the point where we start using the calculator, and then we'll take a break. Okay. Next one, what is the IQR for the distribution of graphing and double serves? What's his spread in terms of IQR? If you don't remember, IQR is the 0.75 minus the 0.25, or it's the 71st percentile minus the 25th percentile. It's the middle 50% of his stuff. So I'm going to draw my same distribution here. Raw Z percent, 115 in the middle, Z score of 0 and 0.5 is a. You guys get used to this 0.5 thing all the time? I'll tell you, some people don't have to do this. In fact, Stanley asked me yesterday, she's like, Mr. Schick, I'm getting all the right answers, but I don't have to draw a picture. Do I have to draw a picture? I'm like, totally not. I draw it because I need to see it. If I don't see it, I lose track of what I'm figuring out. So these two right here, 0.75 is over to the right, and 0.25 is to the left. We're going to get the Z-scores for these. Oh, hey, what? Guess what? We already did that. Do you guys remember the Z-score for the 25th percentile? It's right there. This one's, I'm just going to call it negative 0.68. And does it make sense if this was negative 0.68? Because it's symmetric, this one's positive 0.68. If you don't believe me, you can do this. 0.68 right there, 75th percentile. It totally is. So we're going to do the same equation twice. We're going to do negative 0.68 equals, let's just fill in this stuff, x minus 115 over 6, and positive 0.68 x minus 115 over 6. You're going to solve that twice. You'll get two answers. And their difference is the IQR. So that'll be the distance from there to there. Actually, I've got to do this all at once in my calendar. Who's on smart? Now figure?
And,
What's the difference between those two?
Okay, wait, so then add, and then.
Times that, and then add one.
Six, oh,
Use the numbers?
Yeah.
Do you know what you are? So the IQR is the difference between two of those, Q3 minus Q1. You don't like the staff, that's better. Can we make it easier? Yeah, this is doing it the hard way, there's a cheater way. I'll show you the cheater way. There's always a cheater way. One of the cool things about the EP test, and the EP program is, they know you have that calculator 100% of the time, and it's powerful. It will do all of this stuff in seconds that we're doing in minutes. Yes, it's power of technology. All right, last one on the bottom. A different player has a standing deviation of 8. So somebody cranks it up and they hit it a little harder, and then sometimes because they're swinging harder, they totally like screw up and they don't hit it as far, right? So they're just more, what do you call it, sporadic. They're all over the world, right? Like Dave with driver, right, Dave? If a different player has a standing deviation of 8 on his first serves, and 20% of his serves go less than 100 miles an hour, okay, if the distribution of the speeds is approximately normal, what's his average speed? So this time, what we're going to do is fill in the same sort of fraction, but we're going to put our x over here for 115, is we're going to have a number over here. You follow? It's going to be a little bit different. We're just going to find the mean this time. This is where my variable is. I don't know what his mean is. What's his average? Raw z percent, that's still 0, that's still 0.5. They're telling you he's got a standard deviation of 8. And on his first serve, 20% of his serves go less than 100 miles an hour. So at 100 over here, that's 0.2. If I know the percentile, can I get the z-score? I totally can do that. If I know the percentile, can I get the z-score? Where's 20% on here? I got 20% right here on my chart. I just circled it. It's negative 0.8. It's a lot closer to this one, so I'm just going to call it negative 0.84. Negative 0.84. In this case, the equation we use all the time is z equals x minus mean over standard deviation. I know that number, I know that number, and I know that number. And I get the words missing. Oh, it's more algebra. I'm going to line up the algebra a little bit. So you don't care.
Oh, I know.
Okay, not that loud like me. Okay, negative 0.84. Let's see, the standard deviation is 8 this time, and this x value is 100. Now you're finding the mean, which is going after the minus sign. I will admit, this is a little harder after you do the times 8. Times 100. It doesn't tell you the mean, it tells you the negative mean. So we need to connect it to that. I don't even ask you how to choose the step master. Pretty much. Staff.
Wait, was that what you said over FaceTime the other day?
Uh-huh. Was she trash talking us? That class is so dumb. Oh, okay, that's what it was. Even the staff master needs help now.
Yeah.
Pretty much. All right, I'll tell you what, folks, if you want some help and you're not sure what's going on, now's a good time to like, hey, come ask me. Otherwise, go to the bathroom, go get some water, go take a break. Stand up and stretch. Ooh, do some math yoga. Oh, this is important to me. If I don't do this on a daily basis, my back is screwed, especially with golfing all the time. I played 3 of the last 4 days. I would play yesterday. But my girlfriend's program is senior day for soccer. It's been awesome. It's been awesome. It was great. It was a little chilly.
Yeah.
But hopefully the time March 22nd rolls around. 2.
Yeah, I think it's under first homework.
Was it?
It's under first homework.
First home?
Yeah.
Oh, do you have some questions on homework stuff? Yeah, we could totally do that today. Let me take mine out and then I'll bring it in. I think I got a big pile of it right here. I should ask you about that. Sorry. You good to go there? Yep. You okay, man? You good? Anything out here? Okay. Need a break? You need to go to the bathroom or anything? I'm gonna totally force myself to go to the bathroom. I'm just gonna walk down the hallway and burn 5 minutes and not do anything important. And I'll be right back. Who's gonna be in charge while I'm going? Max is volunteering. Okay, Max is in charge. Will you totally turn into a dictator and go all Hitler on everybody? We'll see. We'll see what happens. Absolute power for us. Absolutely. You guys ready to rock? How are you doing? Yeah, I sure my homework up here in case somebody asks somebody had a question. Anybody else want to talk about homework stuff before we get to other stuff? Yes, Kate says yes, please. Max, which one do you want to talk about? Homework or what?
Homework in 15, check changes, correct?
13. Which give me problem number?
Oh, let's see. Was it number 1?
Problem number 1? I think we already took care of that one. I think you had a problem and you did the right thing. You did 20 out of 35 to 20 out of 100.
14, number 4.
14, number 4, down the very bottom. Okay, so this is kind of a trick question, Max. When you're looking at a normal distribution like this, Okay? You've probably seen me draw this a few times, right? The z-score is right here in the dead center. What's the z-score that's right in the middle? What's the mean z-score? Totally, that's the mean of the z-scores. And then how far do I have to go over here to get to one standard deviation? One. It's 0 and 1. Can you see what I mean by it's kind of a trick question? The mean of the standard deviation of z-scores is 0 and 1. 0 in the middle and standard deviation 1. And then that would be 2 and 3 and so on. That's why we call them standardized scores, because they use standard deviation 1.
Homework 15, number 1B.
15, he says, 1 part B. Okay, so on 1B, so it says using the 68, 95, 99.7 rule, you can see I've got all my guys on here, right? Okay, I've got my standard deviations. There's the mean. And then I went 1, 2, 3 standard deviations left and 1, 2, 3 here. So between 48.7, which is right here, I'll highlight them so it's still up. Between 48.7 and between 67.9, what percent of my data is right there?
16.46.
Well, can I show you my cheater way for doing it? If I went all the way from here, right, to there, that would be 99.7% of the data. You buy that? I'm short of that. How much short of it am I? If I just subtract out this section and this section, I got it. Or actually what I did is I took half of 99.7 and I added 34, because half of 68. I think that's the way I'll do it online. Yeah, I totally did that. I took half of the 99.7, which is from there to there. And then I know it's 16% in the middle, so I took half of 34 to add on.
Half of 97.7 plus 34.
Yeah, there's a 99.7, that's 3 standard deviations, and 99.7, that's from one end to the other, right? And then that'll get me from, there's the 0, then there's 3, there's half of that. And then this part right here will be 34 more, because it's half 68. There's one standard deviation, 68 standard deviation. Are you okay with that? Anything else? Yes, ma'am, whatever.
Question number 2 on that.
Oh, down in the bottom. Okay, so this is annoying. Okay, so how many standard deviations to get all the way from the left side to the right side of your data? How many? Not one. This is +3 and that's -3 for standard deviation.
Oh, 6.
It's 6 of them. And so you're going to take this distance and you're just ballparking that distance, right? Whatever you think it is from there to there, and take that distance divided by 6. This one's going to be a little tighter. That one, whatever that distance is, divided by 6. Same thing with this. This is a little this stretched out. That one goes from about 35 to about 170, or maybe 30 to 70. 30 to 170 is 140. And then take that number divided by 6, and you'll know what the standard deviation approximately is. Okay, it's going to be the ballpark. Okay. Anything else? Other problems? Other assignments? Other stuff? Yes? No, maybe? Anybody letting it pile up on them? Gonna wait like 3 weeks and then have like 10 of them do it? Yeah? It's a strategy. Some people go that way. I wouldn't go that way, but you know, I only turned in all 6 of them yesterday. So, that's how many you should have so far, is a total of 6. And remember, I'll give you full points as long as you do them and do them right and ask for help with your stuff, right? Don't just get yourself hung out to dry. Like, get it down and do it. We gotta have it. I'll give you all the answers. Anything else? Max, did you have any more?
No.
Okay. All right, folks, back to the aspect. We're talking calculators. These forms, a yellow piece of paper. Flip on over to the next page. Okay, yellow piece of paper. You're totally welcome to keep it, right? It's yours. You can do anything you want with it. You can use it to find z-scores and percentiles if you like doing that. You can wear it as a hat. You can fold on it. You can fold it in half twice. Put somebody's name on the front. You can give it to them as a card. I made 3 cards this morning. I'm so proud of myself. Yeah, made some cards today. Or you can throw it in your bin. That's always an option. So we're going to show you how to do this with the calculator. Everything we just did can be done right in here. All this stuff is built into the calculator. All right. How do you do normal calculations on the calculator? The first kind of calculation that you will have to do is to take a z-score and you turn it into a percentile. How do you take a z-score and turn it into a percentile? The command is called Normalcdf. We always go from the low to the high. Low to the high. It's like when you start singing, you know what happens if you start singing too high, like start playing a banner or something? You're doomed. You always want to start it low. It's easier to start low because then when you get to higher notes, you'll be able to actually hit some of them. Double line for me. Other one is how do you turn a percentile into a z-score? That command on your calculator is called inverse norm, and we put in a percent, it'll spit out a z-score. So you're probably wondering, where do I find these magic commands? This one is called Normalcdf, and there's called inverse norm. You have to go under the distra button. There's a button on your calculator that says distra, as in distribution. If you look, you might find it. Distrust, it's like distrust. That sounds awful, to distrust. I don't trust it. It's totally lying. Distribution is right there, folks. I feel like I need my finger pointer. Where's my finger? Yeah, it's right, it's above the bars, B-A-R-S, bars. I can't find my finger. Oh, no. Oh, well, that's it. It's right there above the button bars. So if I turn the calculator on, you're going to want to get to the home screen so you get totally blank. It's always nice to start at the beginning, home screen. To get to the distribution one, you have to hit the second first, hit second, and then that button, and you'll see a list of distribution commands. There's two we're interested in. The first one is number 2, Normalcdf. I'm going to put a 2 right here so I don't forget. That's number 2. It's not number 1. Number 1 is called Normalcdf. We want C for cumulative. Whenever we talk about percentages, whenever we talk about an individual and a percentage, it's always from the bottom up to them. The second one over here, percent to z-score, is number 3, and it's called inverse norm. That means it's going backwards. You're given a percent, it's going to give you a z-score. The inverse norm is easier to use, okay? Let me show you why the inverse norm is easier to use. If I choose number 3, and I hit enter, this is what my screen looks like. Is that showing up okay to you guys? The area is the percentage as a decimal. Okay, I'm going to give it one that I know. I'm going to give it one I know. I know that the 25th percentile, that's Q1, is like negative 0.68. So I'm going to put in 0.25, leave the mean and the standard deviation as 1 because we're talking z-scores. The mean and standard deviation of z-scores is 1. If you put in 0.25, then I'm going to hit paste. It pastes it into the formula for you, so you don't have to type the formula yourself. When you hit enter, you should get the correct z-score, negative 0.674, yada, yada, yada. It's more precise than that yellow table that we have. Okay? Another one to test that you know what you're doing. Go back to the distribution menu, try inverse norm, put in 50%, 0.50. See if your answer makes sense to you. The 50th percentile, the z-score is 0. Probably work. Are we done there? Yes, sir. Question.
What's the internal pace?
Yeah, you have the paste button too there. So check it out. Do you get the same sort of menu that looks like mine's at, or Max?
Whenever I press enter and pick up, I put the same, it just says inverse norm 50.
It's giving you an error of some sort?
What am I supposed to get?
Well, you should get 0 for that one, for 0.5.
Oh, I didn't get it. No, I didn't get that. I just get like formula.
Yeah, you might have to click the enter button or return. You might have to do it twice. Because what it does is it pastes it in. Oh, here, again. Like it. Boom. There it is. Yeah, and some folks, your menu might look different than mine. It might say something over in the far left over here, says something like left. Right? What that is doing is it's asking you, do you want the area below the z-score or above the z-score? Wait a minute. Do you want it below the z-score or above the z-score? Remember how we were doing these problems where we were finding sometimes percent below and sometimes percent above? It'll give you the space above it to the left or the right, depending on what you're at. You should just leave it left as a default. Left is the way to go. Okay. So this is the easier one to use. Why is this one a little bit tougher? Okay. Before we get to that, let's talk about this distribution a little bit. Here's my z-scores. 0, 1, 2, 3. 1, 2, 3. Okay. Is -3 the bottom of the bell curve? Of course, no more after. How much more? What's a lot? I mean, could I be 4 standard deviations below the mean? Could I be 10 standard deviations below the mean? Well, 10's a lot, right? I mean, if you're here, this is 3. Where the heck is 10? 10 is like here. What about 1,000? How about a billion? How about infinity? What is the absolute biggest number that calculator will handle? Have you ever done that with calculators? You're like multiplying until it says error. Of course you do. You type in a whole bunch of 9s, right? Then time a whole bunch of 9s, and you start hitting enter, and you keep doing it until the calculator freaks out. When does it not freak out anymore? How big of a number will that calculator take? That calculator will handle a number in scientific notation all the way to the 99th power. Once it gets to 100th power, it just says, I can't take it anymore, I quit, I give, I cave. Okay? It'll take a scientific notation number all the way up to the 99th power. That is -1 times 10 to the 99th power. It's as big as it goes. And these calculators take things to extremes. When it talks about the bottom end of the bell curve, it's going to go as absolutely far as it can go that way. That's the bottom, right? So when we do this command right here, normal CDF, it's going to usually assume you're talking about the extreme. So let's go into the calculator, go back to your distribution menu. Choose number 2, it says normal CDF, and notice what it tells you in the top line. It usually defaults right to it. You see the -1, E99? That's -1 times 10 to the 99th power. That's a -1, 99 zeros. Is that necessary? Probably not. Once you start talking about the bottom of the bell curve, hey, 4 and 5 standard deviations is pretty extreme already. Okay, this is telling you a number that I don't even have a name for that number. I don't know what it's called. Something like a Googleplex. It's crazy. It's so big. It's not necessary. You don't have to use it. It'll default to that automatically. Then what it says is, okay, that's the extreme infinity that way, right? When you draw a line for a z-score, it's going to give you this percentile. So let's say I wanted, I don't know, like 0.7 right there. That's not 1, that's 0.7. If I put in 0.7 right here for the upper, notice this is lower, this is upper, because it's farthest to the right. And in English, we read from left to right. Does that follow the whole left to right thing? I can't believe how many students in geometry struggle with this is an uphill positive slope. That's a downhill negative slope. People really struggle with that because we read that way all the time. And we do the same thing here. This is lower, this is upper. So the upper being 0.7, 0.7, leave the 0 and the 1 alone. That percentile in the graph that I just created, that's about 75%, according to my calculator. Okay? But you don't have to put in the number that they give you. You can put in anything you want. So let's look at one that's a little bit weirder. This was one from the homework that Max was just asking me about. We had from -3, I think it was up to, was it 2 or 1? It was 1, right? What percentage is that right there? I can use normal CDF to do this. So let's see, distribution, normal CDF. I can change this number to be -3. I can change that one to be, oops, I want a +1. Paste it in. The area right there from -3 to 1 is about 83.9% or about 84%. that's what we got on the homework question. It was about 84%. Somewhere in the ballpark anyway. So this normal CDF is pretty slick, but you gotta be careful what you put in. You gotta think about it sometimes a little bit. All right, should we put it in the action? Let's talk about Zach Greinke. You guys know who Zach Greinke is? Zach Greinke was a pitcher, Major League Baseball, pitched with Kansas City Royals for a long time, bounced around, he was free agent, made buku money, being a hired guy, and he was a strikeout pitcher, threw a lot of strikeouts, threw the ball really hard. Okay, suppose Zach Greinke of Kansas City Royals throws his fastball with a mean velocity of 94 miles an hour and a standard deviation of 2. And that distribution of his fastball speeds can be modeled by normal distribution. All right, about what percentage of fastballs will travel over 100 miles an hour? We can do this. I can't do it unless I do this first. Every time. Okay, the mean we were told was 94. That's right there in the dead center. So it's a z-score of 0, 1.5 from that distribution. We're interested in going over here at 100 miles an hour and figuring out that. I'm just kind of sketching it in there. I don't know that that's really the right percentage that I filled it in. It's about that. I'm going to calculate a z-score, and then I'm going to turn that into a percentage. That would be z equals x minus mean over standard deviation. Okay. So my z-score in this case is 94 over 100 minus 94 over 2. That's, oh, I like that. That's easy. That's 3 standard deviations. There's no law out there of 3 standard deviations. So this is 3. This is where it gets tricky. If this is the area I want and it goes off towards infinity here, does it make sense the 3 here is the lower end of the region? The upper end of the region? What do I put there? You could put a whole bunch of 9s. You could put 10. 4 would probably be good. 3 to 4. Be close. We'll try it a couple ways to see how much it differs. Okay. So we're going to do a normal CDF from 3 up to whatever. Okay, here we go. Second distribution, normal CDF. The bottom end is 3. The top end, I'm going to try like 1,000. Oh, I put 10,000. I went crazy. Okay, that area for this answer is about 0.13%. That's 0.13% of fastballs go more than 100 miles an hour. Cool. I lost my 0.13. Here's the yeah, I'm going to go back and I'm going to do this again. Second distribution, CDF. I'm going to leave that on 3. Watch what happens when I put a 5 right there. Is 5 standard deviations a lot? Yeah, that's pretty far out there. Just 5 or 10,000. Will it make a difference? What do you think? Did it make a difference? It's totally the same. That is the same as that, all the way out to how many decimal places? Like 7 decimal places. You know what pi to 7 decimal places is good for? That's 1/10 millionth in whatever increment you're measuring in. 1/10 millionth. Could you imagine a micrometer that measured to 10 millionths of an inch? I don't even think those one of those microscopes that are really, really tiny. You can see small things. Anyway, 1/10 millionth of an inch is stupid. So the difference between 5 and 10,000 standard deviations was nothing in the answer. Because when you're looking at a bell curve, remember, 3 standard deviations is almost at the end. 4 is just off the edge. 5 is like really out there. There's no difference between 5 and 10,000. Because nothing is 5 standard deviations above the mean except for Babe Ruth. He was the only example I've ever truly seen of 5 standard deviations above the mean. More than that, it was like close to 6. He was ridiculous. All right, let's move on. About what proportion of his fastballs will travel less than 90 miles an hour? So less than 90 miles an hour. Raw Z percent, his mean is 94. 0.5. It was 90 miles an hour, 90 somewhere over here, and we're talking about less than, so that's space. We need to get a z-score, and we'll turn it into a percent. Z equals 90 minus 94 over 2, that's negative 4 over 2, that's negative 2. Negative 2, this is different. This is the top end. This negative 2 is the upper. The lower, that's way out there somewhere. Everybody can do this differently and still get the same answer. Meaning, you can put a bottom number that's different. So, Jenna, what's the last standard deviations for you? Do you want to go out and put 10 million? Okay. Yeah, negative. Yeah, for a z-score. Yeah. I wonder if I did -5, would I be okay? Oh, you can do like -9. You got a favorite number? 7. 7 is a really good number. If you always use -7 for the bottom and +7 for the top, you'd never get any answers wrong. It would be just as good as our 10 million. But Jenna takes things to the extreme, right? It's like your new nickname, you're extreme, the extreme. Jenna, the extreme color. Let's see, normal CDF. And I'm going to go with her, it's -7. And then the upper was negative, the upper is -2 in this case, -2. I get an answer of about 2.3%. Ruby? We down with it so far? Okay, you ready to see how to massively cheat? Massively cheat. All these calculations and fractions are nice to know, and it's important to know how to do them, because you'll get some weird scenarios where they'll ask you to go backwards. You know what I mean by go backwards? We've had a couple problems where you were given the z-score and you were given the mean, and you had to solve for one part of it using the fraction, right? Right? I think I have an example of that right here. See, here we found the mean. Here we found the value, not the mean. It's still using this fraction. You need to know how to use it. However, some people get mad when I show them this, like, why did they do this freaking hard way? What are you doing to me? Oops. Second distribution, go to normal CDF, pull that menu up right there. You probably got some numbers in there and stuff. This works really well for z-scores. Why does it work for z-scores? Because it says 0 for a mean and 1 for a standard deviation. Can I change those? Oh, that's a game changer. Can I change them? What would I like to change them to for the Zach Ricky problem? If what happens if I put the mean in at 94? Wait a minute. If I put the mean at 94 and I make the standard deviation 2. Now when I go up to the upper and the lower, I don't put in z-scores. I can put in real raw things. I could put in, let's see, what was this one? Well, that's the bottom end up to 90, right? So that's, well, let's just say 0 to 90. What percentage of his fastballs go between 0 and 90? 2.3%. Oh, I totally cheated. Because you can change that 0 and 1 to do whatever you want. You follow? See if you can do the next problem in seconds, like me. What percentage of his fastballs go between 93 and 95? Okay, mean standard deviation. You're like, yeah? Did you say anything I got? Oh, you back up. Okay, so we'll just, I hate that this is like a glare on it. You can't see it. Can you see it okay? So on the normal CDF thing, you got what looks like that? What we did was we changed the mean 94 and the standard deviation to 2. Those two guys right there, right? And this question, this next one says, what percentage of fastballs go between 93 and 95? So what I did is I put 93 for the lower, and I put 95 for the upper. Just between those two, what percentage of fastballs will go between those if I put the real mean and standard deviation? Answer, about 38.3%. Does that follow?
Why is that enforced norm we use?
This is normal CDF. This is taking z-scores and turning them into percentiles. If you want to find a percentage, we use normal CDF. This stands for the normal bell curve, and it's cumulative, is what the C stands for, cumulative. It's adding up a bunch of stuff.
What's the lower number supposed to be?
The lower and the upper is the lower bound and the upper bound of the range you're interested in. In this case, Max, the lower is the 93 and the upper is the 95. Okay? Here, see if this makes sense. This is just a logistical, does this follow? What if I make the lower 0 miles an hour and I make the upper 94? What percentage of fastballs go between 0 and 94?
100.
Tells me 0.50000. That's 50%. Why is that 50%? Because 94 is the mean, right? Everything below the mean adds up to 50%. What if I went from 94 as the lower and 10 bazillion as the upper? It should be the other 50%. Okay? So this normal CDF is powerful. It's super powerful. You can get all the answers really fast. So then this question comes up. Hey, Mr. Chip, do I need to show my work in order to get these right? You can get away with writing this down. Normal CDF 93, 95, 94, 2 equals. That counts as showing your work. There's the lower, the upper, this is the mean, and this one is the standard deviation. And you can cheat. That's pretty cool, isn't it? Can you cheat backwards on the other one? All I gotta warn you, now that you've changed these numbers, did you change them and put 94 and 2 in for the mean and standard deviation on your calculator?
Yeah.
Did you change them? Did you change them? That means they're changed. If you want to go back to 0 and 1, you've got to go back and fix it. You know what I mean? If we actually want to use these scores, they're changed. They're permanently changed. Oh no, wait a minute. I don't want 94 and 2 in there. I want that to be 0 and 1. So you got to change it back to 0 and 1 if you want to do another calculation with just these scores, right? So, in every problem, you can change them. The next problem says this. What is the 30th percentile? This time they're giving you a percent and they're saying go backwards and get a speed. How fast does the thing go? So now we're going backwards. This is going to be an inverse norm problem. What does it ask for when I put in an inverse norm? Okay, so what's my lower per percentile? This is from 0 to 0.3%. Whoops, I typed in the wrong thing. I got normal CDF. There we go. Inverse norm. What's the area I want? 30th percentile. That's 0.3. The mean now is not 0 and 1. The mean is 94 and 2. 92.95 miles an hour. So that would be inverse norm of 0.3. Did I say 0.3? Yeah, because that's the area, that's the percentile. And then you're going to put a mean, the standard deviation. And that's 92.95 miles an hour. I wish my bottom 30% of my fastballs went 92.95 miles an hour. I'd make bucks. I have an older brother that could throw a baseball over 90 miles an hour. He's frightening. You guys ever see Game of Thrones? Anybody watch Game of Thrones? Nobody? There's a dude in the TV show Game of Thrones called The Mountain. He's an enormous man. That's what my brother Dale looks like. He's about 6'8", he weighs about 300 pounds, and he doesn't look fat. You know, he's just huge. And he can throw a baseball over because he's just scary big enough. But he's like 60 now, though. It's all right, I can outrun him. I'm faster than him. That's all that matters. He can't catch me. But if he does, I'm in trouble. Okay, last one's in here. What fastball velocities would be considered low outliers for Zach Greinke? Do we want to do the low outliers problem today? I think I want to do that. I think I want to do this. I want you guys to practice this. take this and flip it over to this page. There's a picture of a couple little girls up in the top doing what, 3 or 4-year-old girls do. They stand on books and they measure how tall they are to each other, right? Is that a boy? Okay, well, okay, he can wear a dress, I guess. Anyway, here's some situations, practice ones. According to the CDC, the heights of 2-year-old females are approximately normally distributed. When you see these words right here, approximately normally distributed, you're supposed to think a very specific shape. You should be thinking bell curve, rise, %. With a mean of 94.5 and a standard deviation of 4, what proportion of 3-year-old females are taller than 100 centimeters? Go ahead and give it a try. I'm giving you a couple tools. See if you can answer these questions about these girls. If you're totally stuck and you don't know what you're doing, you call me over. I'll totally help you. I'm nice that way. At least I try to be. Unless I got a room full of freshmen. That's kind of mean. Of course, you were all freshmen at one time. Do you remember being freshmen? Anybody get your hands on anything? You're on the right track there, dude. I like it so far. Equals 4. That's not 4. That's the z. That's what you're finding over here. This would go like z squared, right? Okay, well, let's go like z squared. And then you 1,1.7 I like your start. What you're doing is you're using Z-score here, which is going to be this number right here. Yeah, that's one of these spaces. I scribble on it. You're going to find that area from this Z-score up to the low end. And we'll do everything for Normalcdf. What's up?
What's supposed to do for
Okay, that is the correct Z-score. That's right. Yeah, that's a good number.
affordability thingy? Am I supposed to use inverse norm?
Yeah, if you're going from a percentile, it helps if you draw a picture of the bell curve so that you can get an idea of which part you're finding. Well, this isn't a percentile, that's a Z-score. This is a Z. That's this number here. And what you're going to do is you're going to find from this Z-score 1.38 up to infinity. So this will be the lower and upper one. What percentage is in Z-score 2%. And so you get inverse norm. You want to get. Okay, so the lower is this number 1.38. The upper is probably any deviation to the last one. If you're on that, something big. Get some space there. This was the right Z-score. Okay, so this is your lower right here. The upper is just, would you like 7? 7 is the number. Because 7 is standard deviation. Space it in, and everything is- there it is. Perfect.
But when I'm doing 95, so 9,000.
So you want to type the numbers in, 90 would be, in this case, 90 is below. If we're going between 90 to 95. Okay, but in your case, this is going to work. This should be the answer. That's perfect. For this one, so, yes. So you don't have to do 100% for all this stuff. This 41.9% is that space right there. You're done. All this work was finding the Z-scores. You didn't really have to do it. It's nice that you need to know how to do it. So you use this problem here, right? You get to the heart of it. This particular problem, you just go on the calculator. Everything which is there, it's there. With this standard deviation, or this mean, standard deviation, you're done. You can do this one with an inverse norm. Except the question is written a little screwy, it's actually 80 at 20%. What's up?
Yeah, I remember showing what kind of error.
Okay, let's go back and look at it. So we'll go back to inverse norm, the second distribution. Okay. So the percentage has to be an area as a decimal, a percentage of the space. It's not going to be 80%. Actually, in this case, it's just giving me 20%.
Why is that error?
Because it says 80% of the first row or at least one column. That means this. That 80% is up here. Do you see how that's really 20%?
That was a dumb thing.
So 0.2 or 20%. Now, that that's a good number. Oh, right here. 11 something? Yeah, I can get together all the help later this week that I'm like, why didn't you? I really want it. It's, I have all right now. Yes, you can. Or you want me to do one? Yes, please, I'd like lots of it. Paperwork for the week. Yes, the area is actually a little bit deceiving because when it talks about the 80th% of being at least household, okay, at least means this is 80% here. So what's that area there? That's the 20th percentile. So the area would be 2. And then you can put in your, yeah, and then, and that's going to give you the right answer. That's our public rules. So, paperwork for the week? Okay, you want them anywhere or not? No? Want paperwork? Paperwork? Okay. Paperwork? They're all a bit long. Sir, what's your paperwork for the week? 18, 17, 16. Let's see. Hey, we got 1 minute. 1 minute. Yeah. So tomorrow, what we're going to do when you walk in tomorrow is we'll talk about dragons. Who gets to do the work problems? Do you guys know work problems? Emily's in here, Grady's in here, Andrew's in here, Mr. Armitage in here, Grady. Oh, that's lame. Nobody in here was in any of the work problems. Well, this time, maybe this time. We're going to talk about dragons and stuff. We'll practice this first thing tomorrow, okay? And then we'll do the last section that goes from tomorrow. Oh my gosh. But you know, how everybody wants to feel. Hold on a minute, go away the door. Wait. Not ready. Not ready. Out for a minute. Yes, sir. Yes. Count the door up. I need to put these keys back here or I will forget. What are you doing? My head on my hand. Seriously? Go nuts.
Well, I hope that was fun.